Six Sigma Green Belt Hackathon. How are you? Type in the chat box. आज तो शायद छुट्टी रहेगा ना सबको. Yes. So you must have enjoyed your holiday. Yes. Happy Gandhi Jayanti to everybody. Great. Feeling top of the world. Super, super. That's amazing. Okay, so let's begin our journey from where we had left. And there is a rule called 86-14 rule. Anybody is aware of this 86-14 rule? Just type me in the chat box. Are you aware of the rule called 86-14? Okay, Minitab issue resolved. Fantastic, Sukhbinder. Super. Yeah, anybody knows 86-14 rule? Type yes in the chat box if you are aware of the rule. I think Abhijit ji has said yes. If we do, yes. Fantastic. Okay, yes. So 86-14 rule says, whatever we learn, understand this is very, very important. Huh? Yeah, a couple of you guys are right, but for the other people, whatever we learn, whatever we comprehend, whatever we listen, whatever we understand during the day, 86% of that gets vanished during the same day itself. Only 14% remains in our memory. How fascinating is this rule? And this is after so many experimentation, the scientists have come down to this number, 86-14. Okay. So 86% whatever we learn, we forget. What does it mean? Whatever we have learned yesterday, 86% would have been forgotten by now. So to recover, what we do is to revision and recap, right? So let's do one thing. Before we start today's session, let's quickly revise. You can open your notes and whatever we have covered yesterday, just the topics briefly, can you just type in the chat box randomly? You need not to be in sequence, okay? Like strategic forces and, all the other stuff. But you can be absolutely random. Can you just do this quickly and just recover the 86% till the time the other people also would join us? Yes? Yeah, a lot of people are joining in. So what have we covered yesterday? Chalo, type in the chat box quickly, and then we will start our session. Chalo, let's do the recap. And by the way, recap is done by the people, okay, not by the trainer. Okay. Yes, Cano model. Okay, Cano model is one. Project selection, strategic forces, very nice. So internal project selection, external project selection, the vocabulary, the Lean Six Sigma vocabulary, the SIPOC, yes, supplier input, process output, and customer, very nice. What else? What else have we seen yesterday? Yes. No, AAA gauge R&R, that was done in our live session, not yesterday. Yeah, that was on Monday. Okay. Vocabulary we did yesterday, yes. And Six Sigma vocabulary, Cano or stakeholder analysis, RACI metrics, SIPOC. Okay. Strategic forces, very good. So customer, competitor, potential competitor, all those things are strategic forces. And a very famous, what you can say, quote by ex-GE CEO, right? What was the name? You remember the name of the person? Jack Welch. Yes, Jack Welch. So Jack Welch said that, yes, Jack Welch, ex-CEO of GE, right? So what he said, if the rate of change of internal is less than the rate of change of external, then the death of the organization is near. Okay, very, very important. Not General Motor, it is General Electric, GE, General Electric. Okay, yes. So yes, after that, what have we seen? Statistics. Do you remember statistics? Yesterday we discussed statistics, measure phase. Whatever you measure, you can improve. You will have a better control on that, right? And in statistics, there are two parts: descriptive and inferential statistics, right? Descriptive statistics, inferential statistics. There are two types of data we have seen: Continuous data, discrete data. Remember that? Continuous data, discrete data, descriptive statistics, inferential statistics. Then we have there are three types of measures. Yes, very good. What are the three types of measure? Input measure, process measure, and output measure, right? And we did some exercise around it. After that, what we have seen? और क्या देखा हम लोगों ने? Yes. So within the descriptive statistics, there are two parts. One is central tendency, other is dispersion. Within central tendency, we have mean, mode, median, and in the dispersion, we have range, variance, and standard deviation. So we have covered everything, right? हो गया कुछ recovery हो गया कुछ? Yes? Just give me yes in the chat box so that we can move further. Recovered? Super, super. So today, we will start with something called operational definition. Okay? Ah, very nice, very nice. Abhijit ji, super. Thank you very much for summarizing this. Okay. Soel, can you just copy and paste it to everybody? What Abhijit ji has shared so that everybody will get to know that. Okay. Yeah, just copy and just share it with everybody. No? Very good, very good. Yeah, no issues, no issues. Whatever we have seen yesterday, we have to be present, okay, just to make sure. Okay. Now, coming back to a session, coming back to a topic called operational definition. Just try to understand this, okay? Let me give you a scenario. Now, in measure phase, we collect the data. In measure phase, we collect the data. Now, there are two things. While collecting the data, we can create the variation. Okay. While collecting the data itself, the variation can be created if what type of data needs to be collected, how data is to be collected, if that is not clear. I'll give you an example of this. I always give this example of airline industry. Now, in airline industry, example, if let's say what is that? Aviation industry, let's say aviation ministry wants to compare which airline is what you can say highest percentage of on-time takeoff. Understand this? On-time takeoff. Okay. And domestic airlines where they want to compare. So they collect the data. Now they ask the data from various airlines, right? So let's say, so they ask data from, let's say, Indigo. They ask data from Air India. Okay. They asked data from any airline you can just mention. Then ask data from SpiceJet. SpiceJet hai kya, baby? I don't know. And they ask data from. So let's say Akasa. Okay, Akasa. Yeah. So let's say there are 4 airlines data. They have Air Asia. Okay, let's consider these 4. Okay. So now Indigo. I'm just giving you example. Okay, just for our understanding. Yeah, Vistara is also there. Yeah. Okay. So Indigo says, so they have to collect the data of on time takeoff. Okay. Now understand this. Indigo says, let's say this is, I'm just giving you example. Okay, just for our understanding. If Indigo says when my flight takes the, they put the reverse gear because the aeroplane is parked, right? When it is not flying, it is parked on the bay, right? So when the pilot pushes for the reverse gear and that aeroplane starts to take, takes the pushback from the bay, that is their takeoff time. So they consider that is the takeoff time. Air India says, no, this is not the takeoff time for us. For us, when the plane starts to move and start to taxi towards the runway, that is my takeoff time. SpiceJet would say, no, when it reaches the runway, that is my time of takeoff time. Akasa would say, no, when my airplane actually takes off from the ground, after the running, when it actually takes off from the ground, that is my actual takeoff time. Now tell me, if you compare everybody's data, will it be apple to apple comparison? Type in chat box. Will it be apple to apple comparison? Absolutely no. Yes or no? Correct? So because everybody's way of collecting data is different, that is the reason there will be variation right from the data collection source itself. And to avoid that, we have something called operational definition. Operational definition is a method where we define who will collect the data, what data has to be collected, okay, when that data will be collected, where that data will be stored, etc. Are you understanding? How that data will be collected, what will be the frequency, what is the mechanism of collecting the data. Everything clearly defined, crystal clear, and that definition is called operational definition. Now, once that is clear, that is standardized, then if let's say your operations are on various shifts, okay, and every person in the shift is collecting data, so there will be a standardized understanding across. There will not be a differentiation in the understanding of it. Okay. No, it is not 5Y. It is not 5Y. You can say 5W1H or 5W2H, that kind of thing you can say. But 5Y is Y analysis. Okay, 5 times. So coming back to operational definition. So operational definition is a method to define what data needs to be collected, how that data needs to be collected, where, when, where it will be stored, everything standardized, so that everybody in the project will know what exactly we are doing while collecting the data, so that the variation is reduced. The variation because of the data collection mechanism is reduced. Are you clear? Operational definition, is it clear? Just type yes in the chat box. Super clear, very simple. Just to define on the piece of paper and circulate it to everybody that this person will collect the data at this time, it will be collected, this will be the frequency, this is where it will be stored, everything. Are you understanding? Yes? Clear hai? Yeah, Dr. Shirisha, what you can you just put the headphone? That will be better. Is my voice loud and clear, guys? Give me a yes if it is, right? Clear hai? Yeah, I think headphone. Laptop mein thoda kam aayega. It will be less in laptop directly. Yeah, maybe you can just put a, yeah. All right, clear hai? Yes? Fantastic. So the operational definition is when we collect the data in the measure phase, we have to standardize the understanding of collecting the data. Yeah, very nice. So it's called operational definition. Now, once we collect the data, there is another element which gets added, and that element is called measurement system analysis. That element is called as measurement system analysis. What is measurement system analysis? Measurement system analysis. Now, whenever we collect the data, there are few measurement systems we use. There are few equipments we use. Okay, there are few softwares we use. Just like for example, yes, exactly. So, last couple of weeks, we have taken Gauge R&R and AAA. How many of you were there in the live sessions? Just type me in the chat box. Last couple of weeks, including this week and the last week, we have taken Gauge R&R and AAA sessions, right? How many of you were there in the live sessions? Yes, correct? Measurement system, reliable, or exactly. Fantastic. Okay. So in the green belt level, it is just a brief understanding, brief overview of MSA. Okay. In the black belt level, we go a little deeper. So in the live sessions, we go a little deeper. We do Minitab exercises, explain you everything. What is kappa value? What is GRR score? How it is calculated? What is NDC and all those things. Okay. Here in the green belt level, this is just a brief overview. We need to understand this. Okay. Now, measurement system analysis is actually used to quantify. Understand this. What is the objective? to quantify, write this down, the variation induced because of measurement system. To quantify the variation induced because of the measurement system, it's called measurement system analysis. Now, if you remember that in our fishbone analysis, there are 6 M's: man, machine, method, material, mother nature, and measurement. So all the measurement related variation comes in that column of measurement. Understand this? Okay. And that is called measurement system analysis, MSA, just to make sure whatever is your variation because of the measurement system, induced because of the measurement system, there is a mechanism to quantify it. Okay. So it is called measurement system analysis. So totally, so if I plot the total variation, if let's say this is the total variation, ideally the measurement system variation will look like this. Okay, a small part of it will be, so this is the total variation, and this is variation because of measurement system. Measurement system. Okay, now what statistics of Six Sigma says that before we attack on this total variation, okay, make sure your measurement variation is in control. Okay, so it should not happen. Like, for example, if you are in a weight reduction program and you are doing exercises, you are doing dieting, you are doing everything. Okay, so if you are doing exercises, yoga, weight reduction, diets, etc., so you would check your weight very frequently. What if the variation in your weight, okay, is not because of your diet and yoga and exercises and whatever you're doing, but your weighing scale itself is giving you the variation? How will you come to know that the variation, the reduction of the weight or increase in the weight, is because of my efforts I'm putting in reducing that or controlling that, or that is because of the variation in the weighing scale itself? Okay, so you will not be in a position to measure it. That is the only reason we have to first quantify what variation is coming because of that measurement system. In this case, that weighing scale is your measurement system. Are you clear? The basic fundamental with this example, are you clear with this? Just type yes in the chat box. And in the process, right? In the process, because when we collect the data, we take help of the measurements equipments. Okay, and some part of variation can get induced because of the measurement system itself. Just to quantify that, we have to use measurement system analysis. Okay, funda clear? Very good, very good. Now, so let me just remove this. Now, there are 2 parts in MSA. Okay, MSA is measurement system analysis. Okay, there are 2 parts in MSA. MSA is measurement system analysis. So let me write over here. So there are 2 parts of MSA. If you have continuous data, understand this. If you have continuous data, and if you have discrete data, right? That's what we have seen yesterday. There are 2 types of data, continuous and discrete. When you have continuous data, we go for gauge R and R. And when we have discrete data, we go for attribute agreement analysis. So what kind of data do you have? Accordingly, you have to select whether you want to go for gauge R and R or attribute agreement analysis. Clear? So what is gauge R and R and what is attribute agreement analysis? So let me just briefly cover that. Gauge R and R stands for gauge repeatability and reproducibility. Okay. Now, here in gauge R and R as well, what we check is gauge R and R, GRR value we check. And in AAA, we check kappa value. Okay. Now, coming back to what is R and R. R and R stands for repeatability and reproducibility. Repeatability and reproducibility. What does that mean? Okay. So basically what happens is, according to this is basically this MSA has been adopted in Six Sigma from automotive industry. Okay. Now in automotive industry, there is a global group called AIAG. AIAG stands for Automotive Industry Action Group. Just for your understanding, you can just understand this. Okay. AIAG stands for Automotive Industry Action Group. And this is a body which governs the automotive industries. Okay. So there are some 5 core tools, etc., which is MSA is one of them. Like FMEA is one, and APQP is one, PPAP is one. Okay. So in the master black belt level, basically we cover this in a greater details. Okay. Now in AIAG guidelines, now the best procedures. Okay. Yes, AIAG is from US. There is a counterpart of AIAG, which is the German automotive, because these are the two countries. Of course, Japan also is one of the country which, what can I say, has a very good automotive industry. So AIAG is from US and the German body is called VDA. Okay. Now these people basically has suggested that whenever you want to go for measurement system analysis study, take the 10 samples of any study. For example, let's say if I want to check the the diameter of this pen, so I will take 10 such pens with me. So 10 just such samples I will take. Okay. Then what I will do is I will take 3 people. So every shift. So why 3? Because every shift we have one quality control person, right? And those people generally use those measurement equipment. So I will take such 3 people in the study. And then every person will take the diameter 3 times. That is called 3 trials. So every person will take the same pen and check the diameter 3 times, just to check whether there is any variation in the reading. Okay. So if you consider this 10 into 3 into 3, so there will be total 90 readings we are expecting in measurement system analysis. Okay, just for your understanding. Okay, when we will go to the black belt level, we'll go deeper into MSA, we'll go how to calculate repeatability, reproducibility, etc. We do. Okay. Now just a brief overview is covered in the green belt. Now what is repeatability? Repeatability is nothing but the same sample plus the same equipment, which is the measurement equipment I'm talking about, plus the same person. It's called repeatability. If the same person, for example, if I take the pen, I take the, let's say, vernier caliper, and I check the reading, I check the diameter of that. And if I do it multiple times and give the same reading, that will show the ability, my ability to repeat the same reading. That is called repeatability. Ability to repeat the same reading. Okay, so same sample, same equipment, same person. If that is being repeated, that shows the repeatability. And what is reproducibility? Reproducibility is nothing but the same sample plus same equipment, but different person. A different person. Okay. So same sample, same equipment and different person. That means if I've taken the readings, then I will give the sample to other person. That person also give the same reading. That means it is called reproducibility. Ability to reproduce the same reading by different people. It's called reproducibility. Are you understanding? So repeatability basically is considered to be equipment variation, because the same person, the same sample is there. So whatever variation is coming, this is because of the equipment. And the reproducibility is considered as the variation coming from the appraiser, the person. Okay, that is related to the person's understanding. Okay, the person's capability, person's eyesight, person's, so person related things comes into reproducibility. Okay, you are not able to deliver the same result. Different people are not able to deliver the same result. It's called appraisal's variation. Okay, so what we do generally here in gauge R&R and AAA, we collect those 90 data points. See, in gauge R&R, we collect actual numbers. Okay, for example, we will collect the readings like 10.1, 10.2, 10.3. In terms of discrete data, in terms of attribute agreement analysis, it will be like accept or reject. Okay, accept or reject. That kind of data is there. For example, there is a loan file, loan application. There will be 10 loan applications, and those will be given to 3 different people, the 3 different credit managers. And those credit managers will accept the file or reject the file according to all the documents submitted. Okay, so that is called attribute agreement analysis. Okay, AAA here. So what we do, we collect the data basically and put that data in the Minitab software. Now, if you want to check the how to do that, you must check the live sessions we have conducted last week. Okay, this week and the last week on gauge R&R and AAA, where we have practically did this, put that in the Minitab software. And in case of gauge R&R, we get the GRR value. In case of kappa in case of AAA, we get the Fleece kappa value. Okay, so Fleece kappa is the name of the statistician. On his name, basically, those are given. Okay, so GRR value is something like 1 to 10. Okay, 10%. Like for example, if my GRR is 1 to 10, between 1 to 10%, or maybe 0 to 10. Okay, that is the best system I have. That's the best what you can say measurement system. If that is between 11 to 30, okay, still you can consider that with deviation. Okay, so there is still scope for improvement, but consider under deviation. Okay, so you accept under deviation. And above 30, if it is the variation is above 30, you reject it. Okay, you reject the measurement system, and you have to understand why there is a huge variation. So you have to do the brainstorming. Why my variation of my gauge R&R value is very high? So you can do cause and effect. Okay, do the brainstorming. Is it because of the people understanding? Is it because of the equipment? Is it because of the equipment is not calibrated properly? What exactly is the reason that you need to go into the deeper sense? If it is less than 10%, that's best. You can start collecting the data. Okay, so this is how the GRR value. In terms of kappa value, similar kind of arrangement is there. A little bit of difference you can see here in the kappa value. It is between 1 to 0.9. It is the best. Okay, between 0.89 to 0.7. Again, it is just like accept under deviation. If it is less than 0.7, then you can reject the scale. Okay, so similarly, the kappa value and GRR value, there are values we need to check, and software will give us the value. There are formula to calculate the the manual calculation also you can do. If you are interested, we can do that. But we have this software, and faster we do, we can solve the problem. Okay, so MSA is done basically to quantify the variation induced. If it is less than 10%, that's the best measurement system. If it is between 10 to 30%, still we can accept it under deviation. And if it's greater than 30%, we have to reject the scale. And we should not consider that data unless and until the measurement system is fixed. Okay. After measurement system variation is fixed, then only we should collect, and that data only is considered as authentic data. Are you clear, everybody? MSA is clear, the funda is clear. This much of overview is there in the green belt level. That's it. This much is understanding is required. Okay. The detailed understanding, we go to the black belt level, where we go deeper into how to calculate repeatability, how to calculate reproducibility, how to calculate, how to put the data, how to create worksheet, all those things. Minitab. Okay. Clear? Just give me yes in the chat box, everybody. Super clear hai? Yes. Very nice. Very nice. Now, when we do the our operational definition and measurement system analysis, then we are all ready to collect the data and do the analysis of the data by using the Minitab software. Okay. So everybody, if you are in a position to open your, laptop, desktop with Minitab software, that will be great. We will do some Minitab exercises right now. Okay. Chalo, let's open that quickly. Open your Minitab software. I'll just share some data with you. Okay, so I'm just sharing some data files. Just share some data files with you guys. Oops. Okay. No. Wait. Hold on. So just a second. Now I think you would be able to see that. Okay. I was just sharing to host and panelist only. So only our team members were getting the file. Okay. Now you can download the file called process capability normal. Okay. Can you just download the file and open the file? Okay. Sample collection of every range is the biggest challenge. Which industry you're from? Pooja ji, just type in the chat box. Meanwhile, the people are opening the software. Yeah, can you just check my... Yeah, can you just check the chat? Chat में मैं file share कर रहा हूँ. Just check the chat. You will see a file called Minitab file. Now, if you have the Minitab downloaded, then only it will get opened. Okay. Yeah. Raw material compound. Okay. Now, in the raw material compound, so what do you measure basically in that raw material compound? Is it a continuous data or a discrete data? Is it continuous data or discrete data? Continuous data. Very good. Very good. Okay. So generally, while collecting the data, basically, what you can say, okay, people are asking how to download the file. How many of you have already downloaded the file from the chat? Chat mein jaake just click on the file which is given. It will get downloaded on your laptop. Understand this. If you have mobile phone, it will not get downloaded. Okay. If you have not yet downloaded Minitab, it will not get downloaded. Who is this? Can you just open the name? No, the first, not showing wala. What's the name? Yeah, Hemendra Singh ji. First of all, can you just check see the file over here called process capability normal? Okay, now if you are not in a position to open that file, I'll show you another way. Okay, let me give you another way as well. Just give me a second. Now, if you can open your green belt curriculum. Let me share my screen. Yeah, the people who are not able to, no, not in Word document. Shirisha ji, I think you have not yet downloaded Minitab, I believe, right? So just observe what we're doing. Okay, you'll download it later. Okay, just observe here. When we start with the green belt curriculum, no, let's we start with green belt. So just scroll down in the major phase. Come in the major phase. So we are in the major phase right now. Okay. So in the major phase, you will find something like, let me see, where is the file? It must be in various, let me see the normality test. Okay. Let me see the normality test. Yeah. So in the normality test, now go to the green belt major phase and come to the normality test Minitab exercise, guys. The people who are not in a position to open this, okay? Download the file from the chat. Go to green belt major phase. In the major phase, just look at the normality test Minitab exercise. Just click on start. You will get these exercises. Just download this. Download this file. Everybody, just click on that. It will get downloaded in your laptop, computer, desktop. Everybody got it? In Minitab, in green belt. So the flow is green belt, major phase, normality test, Minitab exercise. Click on start. You will get a lot of exercises, out of which just download this file. Done? Yeah. Just type done in the chat box once you have opened it. Okay. आपने सीपी वगैरह भी कैलकुलेट कर लिया क्या? प्रोसेस कैपेबिलिटी विल गो स्टेप बाय स्टेप. Done. Everybody, the people who could not download the file from the chat, okay? या एक बार ना जूम को अपडेट कर लो. आपका जूम जो है ना उसको थोड़ा सा अपडेट कर लो. The people who are not in a position to open this, okay? Shamalji, that's what I'm saying. Open your green belt certification course in your course LMS system. Open the course, okay? Once you open the green belt course, come to the major phase. Come to the major phase. In the major phase, there is a normality test Minitab exercise. Okay. Just a second. I'll show it once again. How many of you got it, guys? Just type yes in the chat box. Got it, everybody? So this is your green belt curriculum. Okay. In the green belt, scroll down in the major phase. Come in the major phase. After defined phase, there is a Minitab, and then there is a major phase, right? In the major phase, scroll down, and there is something called normality test. Can you see here? Normality test, Minitab exercise. Okay. And click on start. Once I click on start, you will come inside. And once you come inside, then just download this file, normality test chocolate wheat. Done, everybody? दास गुप्ता जी, आर यू डन विद दिस? क्लियर है अभी कहां से जाना है? आपके कोर्स से ही जाना है आप. इफ यू आर नॉट एबल टू डाउनलोड इट, ओके? चलो, लेट मी ओपन अवर Minitab file and let's go to the file itself. Okay. Okay, once you have opened the file, let me know in the chat box. Done, everybody? Open, fantastic. Now, So first what we will do is, go to stat, basic statistics, graphical summary. Okay, now the data is, understand this, the data is the chocolate weight. Okay, there are chocolate weights data has been given. Okay, what we will do is go to stat, basic statistics, graphical summary. Everybody just follow this path. Go to stat, basic statistics. The first option is basic statistics, and in the basic statistics, graphical summary. Now, while navigating, you have to navigate like this. Stat, basic statistics, come on the right hand side and come to your graphical summary. Okay, everybody, once you come here, click on graphical summary, and in the variable option, variable space, okay, just double click on chocolate weight. That's it, chocolate weight grams. That's it. Don't do anything else, and just say okay. I repeat again, listen to me very carefully. Stat, basic statistics, graphical summary. Click on that. Double click on chocolate weight and say okay. And this will appear. If you've got this, just type yes in the chat box. Okay, done. Everybody got this? Clear hai everybody? Anybody behind me, let me know. We will wait for you. Done? Fantastic. Now let's try to understand this. Try to understand this. What is this graph? What do you call this graph? Type in the chat box. What is the name of this graph? Everybody, I want everybody to answer this. You guys are going to be green belt certified people very shortly, so you should understand this. Yeah, this is called histogram. Write this down. Very important. Histogram. So histo meaning historical data, gram meaning the graph. Gram meaning the graph, histo meaning historical data. The graphical representation of historical data is called histogram. And this curve is called normal distribution curve. This curve, it's called normal distribution curve, NDC. The bell-shaped curve. Yes, exactly. Okay. Now, this is called box plot. Okay. And recently, we have taken, I think, just day before yesterday only, right? We have taken a session on box plot. How many of you were present for that session? Just type me in the chat box. This Monday, just the Monday which has just gone, I think it was 30th, huh? 30th of September. Yeah, it was session on box plot. So if you have not seen that, please go ahead and check that out. It is very deeply statistics, basic statistics, and the box plot is created. What do you say? Explain. Now coming back to this. This part is called normality test. We will come to that later. This part, it's called descriptive statistics. You remember descriptive meaning? The description about the current, the sample, because this data is a sample of that. Imagine there is a chocolate factory and they have taken some samples of chocolate, and this is the descriptive statistics. Okay. Mean, mode, median, and all those things. Yes, I think there was a little fluctuation. Am I audible? Yes. Yeah, I think there is some lightning outside. Okay. Recording is on, right? Yeah. I think it is on. Yeah, there was just a small glitch of the fluctuation. Anyways, coming back to, let me share that. Okay, so here, what we need to do is, yeah, just a second, guys. I think because of some heavy lightning, there has been some fluctuation in the internet connectivity here. Just give me a second, okay? Let me switch over to the other internet supply. Just give me a second, okay? Yeah. Yeah, around our office actually. Yes. So yeah, Abhi is stable, right? So I just switched it to the alternate supply of internet. Good. Okay, chalo, let's focus here. So what I was talking about was this descriptive statistics. And this one is inferential statistics. Okay. So descriptive and inferential statistics. Are you clear? Okay. Now, what is descriptive? This is about the sample. So everybody, yesterday we have seen the mean. Yes. You remember that? Trend line is this red line, is it? That red line is called as the bell-shaped curve or normal distribution curve. Okay. Now, everybody remember mean. So the mean for this data is 42.106. Standard deviation. Everybody remember standard deviation sigma, right? So sigma in this case is 1.646. The variance. What is variance? Variance is nothing but the square of the standard deviation. So if I take the square of this, that will be the variance, like sigma square. So variance is nothing but a sigma square. Yesterday we have seen that. So skewness and kurtosis. Skewness is basically a measurement of if their data is skewed or not. Okay. So that we will cover in the black belt level. What is so coming back to this. So skewness and kurtosis. These are these are the two parts which we will cover later. Okay. N is equal to number of data points. So there are 120 data points, 120 samples we have taken. Yes. So yesterday we have seen the minimum, the lowest value, first quartile, median, third quartile, and the maximum value. Do you remember that? Just type yes in the chat box. Do you remember first quartile, second quartile, third quartile? Just type yes in the chat box. Yes, you remember that? Fantastic. Clear? Yes. So this is called the descriptive statistics. And this is called inferential. What is inferential, by the way? If you remember, inferential is about the prediction about the population. No, hypothesis and regression is also inferential statistics. Okay. Confidence interval is also inferential statistics. Hypothesis, regression, design of experimentation, everything is inferential statistics only. Okay. Process capability is also inferential statistics. Right? So what is the inferential statistics? Now, this is about the sample. So this all is about the sample. And let's say the mean is 42.106. With 95% confidence, we can say that with 95% confidence, we can say that the mean of the population will be between 42.808 to 42.403. And there is a formula to calculate, by the way. Okay. With the 95% confidence of the median is 42.1, right? So with 95% confidence, we say that the median of the population will be between 41.58 to 42.32. And yesterday we have seen what is mean, what is median, the difference. Okay. And same goes with the standard deviation. And this is called the inference. We are inferring about the population. That is called inferential statistics. Are you clear? Just type yes in the chat box. Clear hai? So we have seen histogram, we have seen the box plot, we have seen descriptive statistics and inferential statistics. Are you clear with this? Just type yes in the chat box. Super clear hai ye? Any question in this? Super clear? Amazing, amazing. Very good, very good. Chalo. Now, the main part of the data analysis. Okay. Yeah. See, inferential is about. I'm asked to repeat the inferential. Inferential is about, so descriptive, you can write down. Descriptive is about the past. And descriptive is about the sample. Whereas inferential is about the future. Inferential is about the population. Clear, everybody? So one is talking about the sample, other one is talking about the population. Yes? Very good, very good. Clear hai? Samya Durai ji, are you clear with this? Yes, Vasudev ji, you can just put your question in the chat box and I would repeat, I would, what you can say, answer that. Okay? Clear? Very, very. Now, there is something called trend analysis as well. Okay? Let's come back to the data. Now, from here, how will you come back to the data? Now, from the graph, how will you come back to the data? You have to just click over here. See my cursor. Okay. Or there is a short key called Control Alt D. Short key of Control Alt D. You can just press that, you will come to the data. Okay. Now, if I want to check the trend of the data, okay, the trend of the data, there is something called time series plot. What is that? Time series plot. So in the graph, just go to graph and go to time series plot. You can see here from the bottom, there is the fifth option. From the bottom, there is something called time series plot. So the performance of the data against the time, if you want to check, it is called time series plot, right? If you're checking any, let's say Nifty index, everybody check the Nifty index or Sensex, right? That is actually nothing but a time series plot. The movement of that particular parameter against the time, right? So it is called time series plot. Just click on time series plot. As of now, just understand the simple one. Go to OK. And just select chocolate weight and say OK. Just type yes in the chat box once you have done it. Done, everybody? Done, done, done. I repeat again, okay? First, you go back to the data. How to go back to the data from any graph? How to go back to the data? So click over here, or there is a short key called Control Alt D, Control plus Alt plus D. Okay. So you will go back to the data. After you go back to the data, go to graph, go to time series plot. You can see here from the bottom, it is fifth option. Click on that. Select simple, which is by default selected. Here, just select your chocolate weight. Okay, just click on OK. So once you click on OK, you will get to know this graph. Done? Now, can somebody interpret this for me? इसको interpret करो जरा. What is your observe? Just observe it for some time. Now let me just give you how to observe a graph. Okay, let me give you some secrets behind observation of the graph. Just observe it and tell me what are you observing. Just observe the graph and tell what that graph is talking to you. This is not control chart. This is not control chart. This is just a time series plot. There is a difference. I'll show you what is the difference, but this is not control chart. Okay. What is this graph telling you? Just look at the graph and observe. And what are your observation? 60 number is having the highest weight. Okay, that's interesting. Yeah. Around 60. Yes, very good. What else? Variation, very good. So there is a huge variation you are observing. Are you observing the huge variation? So the first one is huge variation. Yes. Correct. Variation is very high. There are few peaks and valleys I can observe. There are few peaks here, here, here. And there are few valleys like this, this, and this. Are you understanding? So there is huge variation. Another thing is that the peaks and the valleys are very close to each other. How many of you are observing? Can you see here? Look at this. Look at this dot, and immediate after that, this graph at immediate, there is a huge spike. Can you see here? So the variation, look at this graph. After that, there is this graph and it goes down. So the variations are, for example, look at this graph, this dot. The next dot is exactly on the other side, just like a pendulum. Are you observing? The peaks and the valleys are subsequent. Very interesting observation. Are you observing this? This is how, once you observe, the graph will start to speak with you. Are you understanding? This is how the graph will start to speak with you. Another observation, if you very, very closely observe, let's say if I draw the very basic lines over here, up to just, let's say, 50 or 55 number, suddenly you will find the variation has increased. How many of you are observed? Suddenly after that, there is a shift in the process. Are you observing this? So more your eye will get familiarized with capturing these trends and patterns. Yes, exactly. So this is where you need to make sure that you need to observe the trends and the patterns. So software will give you trend. You need to observe those trends and investigate. So time series plot is a very important tool to basically investigate what is happening. Okay. Yesterday, we discussed about voice of process. Do you remember this terminology, voice of process? Just type yes in the chat box. Do you remember what is voice of process? I said, what do you mean by voice of process? In the vocabulary, we mentioned voice of process. What is that? Yes, voice of customer is what customer is talking about our feedback and complaint and all those things, right? But how process will speak? Process will speak through data, through graphs. And this is called voice of process. Are you understanding? Okay. Now here, This is, so we cannot conclude, but from here we get, understand this, sir? Now you remember this equation. From data, we get information. So from data, we convert that into, let's say, graph. From graph, we get some information. And from information, we get wisdom. And this is how our understanding gets deeper about our own process. So we need to investigate. What is the reason of this? What is the reason of this immediate shift? यहाँ पे exactly क्या हुआ था? I can see completely two different processes. A process with a less variation and a process with a very high variation. What has happened? Is it the people have changed, the supplier has changed, what what you can say, the environment has changed, what exactly has shifted? That we need to investigate. And investigation will let us to the wisdom, which is the most important thing. Are you clear? And this is called time series plot. Clear here? So where will you use this in your company? Type in the chat box. Where will you use this in your company? Where will you use this? So, yeah, so this is, we have to investigate, no? Graph will just tell you that this is what we are finding the trend. Now, this is your role to go back to the records, speak with the. Wow. So I think there are a lot of things. Okay, coming back to the data. Coming back to my graph again. So what you need to do is the peaks and the valleys have to be investigated. That is our rule. So graph will tell us that what is wrong, what are the variations, and those variations have to be investigated by us. Clear hai? Are you clear? Just type yes in the chat box. So where will you use this? Type in the chat box. Where will you use this? Where will you use this time series plot in your organization? कहां पे आप यूज करोगे? Once you are clear about that, then you are good to go. Implementation is very important. Where will you use this? Yes, overwise runs. Okay, yes, you can see that overwise runs. Okay, what else? Manufacturing process. Yes, very good. Running process, correct. All the parameters of the process you can put in the time series plot. Pump alignment, measurement of pump alignment. Okay, you can say that. Hourly production, very good. Per hour, how much production you are doing. Continuous process readings, very nice. Super. Are you clear? Okay, so it can be temperature, pressure, whatever you want to monitor against the time. So in the x-axis is time. In the y-axis, whatever parameter you want to measure, you can measure. Clear? Very good. Now try to understand this. There is another graph which is called control chart, which is similar to that. Only thing is that it will have 3 different lines to that. Okay. In the control chart, there will be a center line, which will be the average line, which is called as the mean, X bar. Okay. There is a line called control limit, which we call it as upper control limit. And there will be a line of lower control limit. And what is the formula to calculate upper control limit? Now, this is I'm talking about is control chart. What is the difference between? And we will do it right now. Okay. So control chart is basically is to check whether the process is stable or not. Okay. To check the process, whether the process is stable or not, we do a control chart of it. So in the control chart, it is exactly same as the time series plot, but there are 3 lines along with the time series plot are getting added. First is called X bar, which is the mean, simple mean, the average line. And there is UCL. What is UCL? UCL, the formula is X bar plus 3 times standard deviation. And what is LCL? The formula is X bar minus 3 times standard deviation. Okay, just for our understanding. Let me give you example. Let's say X bar is around 42. Imagine X bar is around 42 and standard deviation is around, let's say, 2. Okay. Can you calculate UCL and LCL for me with this formula? X bar is 42 and standard deviation, sigma is 2. Can you just calculate UCL and LCL for me? Type in the chat box quickly. Very simple example. I've given you all the formulae, all the values as well. Just calculate and give me the answer. UCL is what? UCL is, so it will be like X bar is 42 plus 3 times standard deviation, which is 2. So 42 plus 6 is equal to 48. So upper control limit, what is UCL? It's called upper control limit will be at 48. Clear hai? And what is the lower control limit? X bar minus. So 42 minus 3 times standard deviation, which is equal to 42 minus 6 is equal to 36, right? So LCL will be at 36. Clear, everybody? And X bar is simple average. X bar is simple average of the data point, mean. Okay. So if any data point which goes beyond the control limit, okay, if anything which is within the control limit, this variation is called, write this down, common cause variation. Common cause variation. Okay. And the variation beyond these lines, these two lines, upper control and lower control, it's called, if let's say one data point is going like this, okay, this is called what? Anybody? Called special cause variation. Here? Yes, assignable cause or special cause variation. Okay? So within the two limits, control limits, if there is a variation, it's called common cause variation. If it is going beyond control limits, it is called special cause variation or assignable cause, because you can assign the cause to that variation. Okay. Common cause, you may not be able to assign the cause for it. So just to give you a very simple example, every day you go to office, there is a common cause variation, right? 9 o'clock is the office time. So you reach around 8:50 to 9:10. So between this, there is a common cause variation. But one day, your car gets breakdown and you reach 1 hour late. You reach at 10 o'clock. That is a special cause variation because there was a specific reason for that. And for the common cause variation, this is regular reason like regular traffic, regular, what I can say, preparation time variation and all those things, right? So it is called common cause and special cause variation. Are you clear with this? And this chart is called control chart. Are you clear the basic fundamental of control chart? Are you clear with this? Just type yes in the chat box. No, this is not called outlier. Technically, it is called special cause variation. Okay? Clear, eh? Very good. Now let's do this right away. Let's do this right away. Let's go back to the data once again. Go back to the data once again by clicking on this window. All you can do Control Alt D, right? Remember that? Correct. So this is your data. Now we will do what? We want to do a control chart. So you go to Stat, Quality Tools. So Stat, Control Charts. You go to Individual, Variable Chart for Individual. Just follow this path. Stat, Control Chart, Variable Charts for Individual. Everybody follow the path and just click on Individual. stat control chart, variable control chart for individual. Just click on that. This window will appear. Just select chocolate weight column into this variable column. That's it. And say OK. Everybody got this? Just type yes in the chat box. Let me show you both the graphs, okay? Let me show you both the graphs. And let me put them side by side for your understanding. Look at this. These are exactly same graphs with 3 different lines got added, right? Time series plot and control chart. Clear? Yes, so same graph, only these 3 lines are getting added, mean, UCL and LCL. Clear? And now let me open this. So in this case, can you see here, only one dot which is very close to the upper control, just touching the control limit. Okay. Otherwise, all the data points are within the control limits. So this process is called stable process. Any process which runs within +3 and -3 standard deviation, it's called as a stable process according to Walter Shewhart. Write this down. Who is Walter Shewhart? Walter Shewhart is father of statistical process control. Yeah, so the values of UCL and LCL are different because I have just given you the rounded off numbers. I have given you X bar is equal to 42 and sigma is equal to 2, just for our simplicity. If I would have given you, let's calculate standard deviation at 1.798. Okay, just calculate. So that would have been a little complicated. That's what I just made it very simple. Okay. And X bar is also 42.106, right? That's why the UCL and LCL are different than what we calculate. Okay. Clear? I just rounded off the numbers so that you will get some understanding of it. Okay. So this is the stable. So from your process also, you can just collect the data, put that process in the control chart and check whether your process is stable or not. Are you clear with this? Just type yes in the chat box. Are you clear? Just give me yes. Super clear. Very, very much clear. Very nice. Very nice. Now, there are very, very important things. Now, before we go for, see, ideal objective of the what you can say, the major phase is the process capability. Okay. Let me go back to my whiteboard and explain you this. Okay. Let me just go back to whiteboard. So it's so close can be a common cause only. Yes. You can consider that is as good as common cause because it's just touching the dot, right? Yes. So now let me just remove this and understand. This is very, very important. Huh? We have just talked about S. Okay, let me just remove this. I will not use this. Let me use this one. Okay. So we have just spoken about S for stability. Okay. So stability is done with the help of control chart. Okay. Now the next part we do, it's called N for normality. Make a note of this. Normality. Okay. And normality is done with Anderson-Darling normality test. Write this down. Anderson-Darling normality test. Okay. And after that, we do C, which is called capability. What is that? Capability. Okay. Now, which is done through capability analysis. Capability analysis. Okay. So, what we have done till now, stability we have done, right? So, how do you remember this sequence? This sequence is very, very important. First, we check the stability of the process through control chart. Okay. Second, we check the normality of the data through Anderson-Darling normality test. And third, we can do capability analysis through capability. And how do you remember this? Remember this with S, N, and C. Everybody, please type S, N, C in the chat box. Stability, normality, and capability. Remember S and C, so that will get very clear in your mind. First do the stability, then do the normality, and then do the capability. Okay? So stability we have already done with the control chart. Let's do the normality and then the capability. Okay. Actually, normality we have already done. But I will first cover normality, then I will explain you. Okay. So again, go back to the same data. Go back to the same data here. Okay. So this is my data. How do I find out the normality test? Go to stat, basic statistics, normality test. Everybody? Yes, histogram also shows the data is normal, but that is not confirmation. Okay, histogram will not give you the exact statistical result. So we are going to check that with the normality test. Okay. So everybody go to stat, basic statistics, normality test. Okay. Click on normality test. Okay. Select chocolate weight. And there is test for normality which says Anderson-Darling. Okay, there are two statisticians named. One is Theodore Anderson and second is Donald Darling. Okay, on these two people, this statistical test is named after. Okay, just click on OK, and this will come. Clear? Now look at this. Everybody got this graph? Just type yes in the chat box if you got this graph. Stat, basic statistics, normality test. Okay. Now, what is normality? What are we checking basically? Whether the data is normally distributed like this. Okay. Or whether the data is skewed distribution like this. Skewed meaning non-normal distribution. Are you understanding? So this is what we are checking right now. And how do we confirm this? One thing is that the histogram. So histogram will give us one hint whether the data is normal, but it will not confirm. Histogram never confirms whether the data is normally distributed or not. What gives us the confirmation is this normality test. Okay, look at this. So the first one is mean. Mean is got 42.11. We have already done that. Standard deviation sigma is 1.64. N is equal to number of data points. Then this is the AD. AD is the calculated value of Anderson-Darling statistic. Okay. From AD value, we check the P value. And for us, AD value has got no meaning. For us, P value is the most important thing. Okay. If P value is greater than 0.05, then the data is normally distributed. If the P value is less than 0.05, the data is said to be non-normal or skewed distribution. Now, in this case, is it normal distributed or skewed distributed? Type in the chat box. Is it normal or skewed? P value is probability value. P value is probability value. I'll cover that in the second half today itself. I will cover that. We'll cover hypothesis testing today. Okay. Clear? Data क्या है फिर? Normal है कि non-normal है? Check the P value. If it is greater than 0.05, it is normal. If it is less than 0.05, it is non-normal. What is the still people are saying non-normal. It is normal, right? Yes, exactly. It is normal. And another hint is that if the data is normal, see, this line is called line of significance. This line is called line of significance. Okay. If the data is very close to the line of significance, that also indicates the data is normal. If the data is non-normal, the data will be a little scattered like this. Okay, somewhere like this. Okay, so if it is very close to the line of significance, that means it is a normal. But ultimately, we have to check the p-value. That's it. And what is p-value? I'm going to just discuss about it when I'll go to explain about the hypothesis testing today. Okay, clear? So this is called normality test. So first we do the stability and then the normality. Okay, now we have already done this test before. Let me show you that. You want to see where we have done that? We have done that in this. Can you see here? Anderson-Darling normality test, p-value. Just type yes in the chat box. We have already done that in the graphical summary. The first graph we have made, right? Correct? Yes. Very good. And now, so we have done the stability, we have done the normality. Now this is the time to do the process capability analysis. Okay. Now, what is process capability? Just try to understand. Ability of the process to satisfy the requirement of the customer. Ability of the process to satisfy the requirement of the customer is called process capability. Ability of the process to satisfy the requirement of the customer. So we need customer requirement, right? And what are the customer requirements? They are called lower specification limit and upper specification limit. And it is not control limit. Control limits and specification limits are different. Are you understanding? These are called specification limits and they are decided by the customer. Are you understanding? Okay. So once we know the specification limits, you must have seen in your organization, right? 10 plus minus 1. What does it mean? Customer wants 10 to be the target, 9 to be the lower specification limit. Target will be 10 and 11 will be the upper specification limit. Are you clear? 10 plus minus 1 is equal to this. Are you clear? This is called specification limit given by the customer. Clear? Just type yes in the chat box. Super clear with this? Everybody? Just give me yes. Once again. All right. Let me just come back once again. Yes. So are you clear with this specification limit, guys? Specification limit is clear. Just type yes. Now let's differentiate with specification limit here. Let me remove this. If you're taking the notes, let's do one thing. Write control limit and specification limit. Control limit and specification limit. Okay, so I think super. Guys, understand this. There is huge fluctuation of internet right now here, and that is what is checking. Okay, now coming back to this control limit, specification limit. Okay. Now understand this. Make a line between this. Control limits are decided by the process itself. Process decides control limit. And specification limits, customer decides. Write this down. Okay. For control limits, we have control charts. For specification limit, we can put specification limit to histogram and check the capability. Okay. Control limits shows us the stability of the data, and specification limits shows the capability of the data or the process. So control limit shows whether the process is stable or not, and specification limits shows the process is capable or not. Okay. If the data goes out of the control limit, that is called as special cause variation. And if the data is going beyond specification limit, it's called what? If the data is going beyond control limit, it's called special cause variation. If the data is going beyond specification limit, it's called what? Type in the chat box. Everybody, think about it. Yeah, I will come to 6 sigma, 5 sigma, 3 sigma. After that, it will come. No, it is not outlier. It is not. Yeah, you can say, so it is called as a defect. Write this down. Defect, rejection, non-conformity, all these things are, if it goes beyond specification limit, customer will not accept it. Clear? Everybody? So there's a difference between control limit and specification limit. Is it clear? Just type yes in the chat box. Very good. Now let's find out what is the process capability. So stability we have done. SNC, we have done stability, we have done normality. Now we will do capability. Okay. To do the capability, just go back to the data. And imagine our specification limits are lower specification is 36 and upper is 48. Okay. Imagine that lower is 36 and upper is 48. Okay. Let's go to stat, quality tools, capability analysis, normal. Everybody just follow this path. Stat, quality tools, capability analysis, normal. Stat, quality tools, capability analysis, normal. All right. So just click on this normal. And you will come to this. Okay. I repeat once again. Stat, quality tools, capability analysis, normal. Everybody with me till now? Stat, quality tools, capability analysis, normal. Click on normal. You will come to this. In the single column, just select chocolate weight. In the subgroup column, just put 1. Subgroup is a group of the sample we are taking. Just as of now, we will consider only 1. So 1 sample at a time we are taken. Okay, that is what we are considering. In the lower specification limit, you have to put 36 because that is our lower specification limit. And our upper specification limit is 48. That means customer will accept the chocolate weight within 36 and 48. Within 36 and 48. Are you clear? Yes? Just type OK. Yeah. Before we click on OK. Yes, 36 and 48. Before we click on OK. Yeah, subgroup size is 1 because we are considering every sample, every subgroup. Subgroup meaning, see, understand this. There are two types of sampling we are doing. One is we are taking one sample at a time, or we are taking group of samples. If we are taking group of samples, that is called subgroup. Are you understanding? Right now, we are only considering we are taking one chocolate at a time. That is called subgroup size is 1. Clear? Okay. Are you considering? Yes. Very good. Now go to option. Go to option, guys. And here, instead of over here, just select the benchmark Z. Select benchmark Z. Okay. Go to option and select benchmark Z here. Okay. And click on OK. And click on OK. Everybody got it? Just type yes in the chat box if you have got this. I'll repeat again. I'll repeat the entire process. Go to stat, quality tools, capability analysis normal. Okay. This is the process. Stat, quality tools, capability analysis normal. Once you click on normal, this window will appear. Okay. In the single column, select the chocolate weight. Subgroup column, select 1. Lower specification is 36. Upper specification is 48. Go to option. Here there is an option column. See my cursor. On the right hand side, there is an option column. Here, just click on benchmark Z. Just see my cursor. Benchmark Z. Just select that option. Click on OK and click on OK. Okay. Yeah, don't do anything in tolerance, K value, etc. Let it be as it is. Let it be 6 only. Okay, tolerance K value is considered as 6 only. Okay. And say okay. Once we do that, you will get this value. Everybody now got it? Just type yes in the chat box. Fantastic. Okay. Now, what is this? Very, very simple. Okay. Right now, because we have considered, okay. So this is your current process capability, which is, so right now your process is 3.46 sigma process. That's it. This is my Z score. This is my sigma. You know, remember, right? 2 sigma process, 3 sigma process, 4 sigma process, 6 sigma process. Similarly, right now your process is 3.46 sigma process. You just have to see this Z bench value. Simple. This is your current process capability. Now, after you improve the process, okay, what we'll do, your role is to reduce the variation, right? So once you reduce the variation, your sigma level will go up. Okay, then it will become maybe 4.5 sigma. Are you understanding? That is where you will do after improvement. You can compare this. That's why this process capability is done. Are you clear? Just type yes in the chat box. Super clear. Everybody is clear about this. Just type yes in the chat box. Super clear, hai? That's it. So you have to just put the data in and just check this Z value. That's it. Okay. If the Z value is 3.46, that means your process is 3.46 sigma. And this 3.46 is your capability number, which you want to improve. As you reduce the process variation, your capability number will go up. What is this 3.46, guys? Understand this. Which means, try to understand this. What is this z-score? What is the formula of z-score? Let me give you a quick answer to that, because a lot of you are asking the question. The z-score is, I'll give you a practical example of this, okay? Imagine this is a process. Okay. This is the mean X bar. This is, let's say, upper specification limit. This is lower specification limit. Okay. Now imagine in this process, the formula of z-score is USL minus X bar divided by sigma. I'll give you some values over here. Okay, USL is, let's say, 48. X bar is 42, which is the mean. And imagine standard deviation is 2. Can you find out the z-score of this? Three. When the z-score is 3, it is called 3 sigma process. Are you clear? Are you understanding this? Now understand this. In a simple word, what is my X bar? X bar is 42, na? And my USL is 48. Understand this? Now this is very, very important. I can fit 3 times standard deviation. Because my standard deviation is 2, right? I can fit 2, 2, and 2, 3 times. If I can fit 3 times standard deviation, that means my z-score is 3 sigma. Because my standard deviation is 2. No, USL and LSL is given by the customer. We never decide. USL and LSL is decided by the customer. Customer gives USL is 48, LSL is 36. I want product within this. Try to absorb this, guys. My mean is 42. That's what I have given you. What I have given you, my USL is equal to 48. Yes or no? My mean is 42. And my sigma is 2. How many sigmas I can fit between my mean and my USL? I can fit 3 sigma. 1, 2, and 3. If I can fit 3 standard deviation, that is my 3 sigma process. How many of you got this? Just type got it in the chat box. How many of you got this? Just type got it in the chat box. Now, imagine, let me give you another thing. If my sigma is 1, imagine, and what is sigma? Sigma is my standard deviation, right? If I reduce my variation, understand this, my process will come very close to my mean. And it will look like this, something like this. Okay, let me just see where it is, right? Yes. So it will come very close. So I'll draw here. Okay. Earlier it was here like this. Now it will come very close to the mean. Are you understanding? When my sigma is 1, how many standard deviation I can fit between 48 and 2? Type in the chat box. How many standard deviation I can fit? Guys, just listen to me very carefully. Between 48 and 42, if my standard deviation is 1, sigma is 1, how many standard deviation I can fit? 6, no. Yes. I can fit 6, no, 6 standard deviation. Nahi samjha. I draw it here. Let me remove this, okay? Let me remove everything. This is my center. This is my mean. This is my USL. This is my LSL. Okay, between this, now this is 42 and this is 48. Okay, so distance is 6, right? If my sigma is 6, I can fit 6 sigmas, na? 1, 2, 3, 4, 5, and 6. When I can say fit 6 times standard deviation, it is called 6 sigma process. How many of you got the bulb bond moment right now? When my standard deviation is 1, when my standard deviation is 1, okay, so look at this. This is my standard deviation 2. And if I reduce my variation, this is my standard deviation 1. It will reduce. When my process is reduced, the variation is reduced, my sigma will reduce. When my standard deviation sigma will reduce, I can fit more standard deviation between my mean. This is my mean. And this is my USL. And the formula is very simple. Z is equal to USL minus X bar divided by standard deviation. You reduce the standard deviation, you increase the Z value. Got it now, Lakshmi Shankar, got it? Very simple. How many of you are not got it yet? Just type me in the chat box. Not got it, huh? Just type not got it in the chat box. Got it? Very simple. So our role is just to reduce the variation and increase the process capability. That is our role. Clear now? How many of you got the bulb bond moment today? Type BO in the chat box. Bulb on. BO is bulb on. Bulb on. Fantastic. Fantastic. Super. Super. Okay. Clear है? Okay. Now coming back to this. जिनको नहीं समझ में आया है, आपको सिर्फ प्रोसेस कैपेबिलिटी चेक करनी है and just select this. This is your current process capability. That's it. Don't worry about this. This is your current process capability. After the project, do the same process and this has to go up. Then your process is successful. बल्ब मूवमेंट नहीं, बल्ब ऑन मूवमेंट. बल्ब ऑन मतलब दिमाग की बत्ती जल गई, अभिजीत जी. इट्स नॉट बल्ब मूवमेंट, इट इज बल्ब ऑन मूवमेंट. जब दिमाग की बत्ती जल गई बोलते हैं ना बल्ब ऑन मूवमेंट. ओके, टिंग. No, when we understand the concept, दिमाग की बत्ती जल गई, we say that, right? That's what called bulb on movement. Yeah, bulb on. It's not bulb. So I was wondering what he is asking. Okay, bulb movement. Bulb on movement. Okay, BO, bulb on movement. Okay. Yes. Clear hai? Very good. Now, okay, now understand this. I just got a message from my team that, the internet cord got damaged because of some reason here in my office. So right now, what we will do is we have to stop our session today. We cannot continue the session because there will be a lot of fluctuations. Okay, you would have experienced this, right? This was because of some, the cable has got damage. So what I will do is, so we have covered the major phase, right? So whatever analyze phase part, hypothesis testing, okay? That hypothesis testing part, I will share with you as a recording of the earlier hackathon. Okay, so earlier hackathon recording I will share with you. Please observe this hackathon recording, and we will stop the session right now. We cannot continue because there will be a lot of disruptions because of the internet connectivity issue today. Okay, are you clear with this? Yeah. So the dotted line is within capability and overall capability. Okay. So this red dot is the the overall capability as we have seen, and the within capability this. What is within and what is overall? Let's try to understand this. If we are taking the subgroup samples of 10 chocolates, okay. So within the chocolate subgroup, there is a variation, right? So this first subgroup, second subgroup, third subgroup, fourth subgroup. So see, n is equal to 120, right? You can see here. Total 120 data points are there. So they have taken 12 samples like this of 10 chocolates each. Now, every subgroup has got some variation, and that is called within variation. And if you mix all the 120 chocolates together, that is called the overall. Okay, because we have considered one sample size, that's the reason we are considering only overall, and we are not considering within process capability. Okay. Yes. Yeah. Now, how will you access the hackathon recording? Let me just show you that quickly. Let me open the hackathon recording. There is a folder called hackathon folder in our courses. There is some